Alright guys, today we're going to continue talking about exponents. Now this video will deal with rules 5 and 6. In a previous video I talked about rules 1 through 4. And just to review that, here is our base number, and this number to the upper right corner is the exponent, or the power. And what that basically means is how many times the base number will be multiplied by itself. So you can see I have an example down here of x squared, which is x times x, and x cubed, which is x times x times x, and then x to the 6th, which is x times itself 6 times. So rule 5 will deal with division. And rule 5 states that when dividing exponents, subtract the powers of like terms. You can see I have y to the third and y to the first. Okay? Those are your like bases. So when we subtract 3 minus 1, we get 2. And so in this case, we're left with y squared. On a second example, we have y to the 8th, x to the 5th, over y to the 3rd. My like bases are my y's again. And I have y to the 8th and y to the 3rd. So when I subtract them, I am left with y to the 5th, and I have nothing to affect the x to the 5th there, so my answer for that one is y to the 5th, x to the 5th. It is important to note that it does matter whether the greater number of your power is in the numerator or denominator, because that's going to determine where it ends up in your answer. For example, on the next example here, I've got w to the 4th, b to the 5th over w to the 8th. Now we all know that w to the 8th is a larger power than w to the 4th. We still do subtract those, but in this case, since when we subtract there are more w's on the bottom, the w's will still be in the denominator of that fraction. The w's in the numerator all become 1. So it would end up being 1 times b to the 5th, or just b to the 5th, and then w to the 4th. And then in the third example here, I've got a negative exponent that I am working with. So remember, the negative exponent up here, in order for it to be positive, would move down to the denominator, and then I'd have c to the 3rd, c to the 4th. I can put those together by adding those exponents together to get c to the 7th. Then I have b to the 6th over b to the 7th. When I subtract those exponents, I'll be left with just 1b in the denominator. And I do not have nothing up in my numerator. I have 1, because what is happening is the same thing when you have an 8 over an 8 in a fraction. That doesn't become 0, it becomes 1. Just because these are letters doesn't change the fact that any number or letter over itself in a fraction becomes 1. So our numerator in this case becomes 1. Okay, and then for rule 6, when raising a fraction to a power, both numerator and denominator are affected by that power. Okay, so you can see here we have a over b squared. In that case, it becomes a squared over b squared. If we look at the second example, we have j to the 3rd, b to the 4th, all raised to the 5th power. In that case, remember that when we're raising a power to a power, we multiply those powers. So 3 times 5 is 15, that would be j to the 15th. 4 times 5 is 20, b to the 20th. And then in the last example here, there's a lot going on. We have 9v e to the negative 2nd, over 3v to the negative 3rd e to the negative 1st, all raised to the 3rd power. Yeah, that's a lot. Okay, so everything inside these parentheses is going to be cubed. That includes the 9. So 9 cubed leaves us with 729. V cubed leaves us with v to the third. And then e to the negative second leaves us with e to the negative sixth. The 3 cubed leaves us with 27. The v to the negative third already leaves us with v to the negative ninth. And then the e to the negative first cubed leaves us with e to the negative third. So then, when we have whole numbers, we can just work with those. If they can be divided, then you divide them. So 729 divided by 27 is actually 27. With the v's, the v in the denominator to the negative ninth, the v to the negative ninth, in order to make that positive, needs to go up to the numerator, and then we can combine that with v to the third and end up with v to the 12th. And then finally, the e's in both the numerator and denominator, in order for them to be positive, need to change levels. So the e to the 6th needs to come downstairs to the denominator, e to the third needs to go upstairs, and then we can subtract the e to the third that is now in the numerator over e to the third, e to the 6th that is now in the denominator. And since there are going to be 3 more e's on the bottom, that is what it will end up with. So solving this one here, we'd get 27 v to the 12th over e to the third. And that's it for our exponent rules. We're going to definitely practice this in class, and I look forward to seeing you there. Os!